this video, we will focus on Internet Protocol. Here are some interesting facts about Internet Protocol. Internet Protocol is the principal communication protocol in the Internet Protocol suite. IP is a set of rules for routing and addressing packets of data, enabling the data packets to travel across networks and arrive at the correct destination. This protocol is responsible for addressing and fragmentation of data packets. Routing function of the Internet Protocol enables Internet working and essentially establishes the Internet. To be able to send a packet from sender to addressee, the Internet Protocol creates a packet structure which summarizes the sent information. This packet format is known as an IP datagram. Although there are two IP versions, namely IP version 4 and IP version 6, we will consider only about the IP version 4 datagram. Every IP header always begins with a 4-bit long specification of the Internet Protocol version number, either IPv4 or IPv6. Next 4 bits inform about the length of the IP header, as it varies. The length of the header is calculated by multiplying this value by 32 bits. The minimum value of head length is 5, as 160 bits or 20 bytes is the minimum size of the IP header. Type of service allows the network to make adaptations for delay, throughput, or reliability. Total length is the length of the entire datagram in octets, including the header. This is why an IP datagram can be up to 65,535 bytes long, as that is the maximum value of this 16-bit field. In situations where a network device in the transmission path cannot handle the original size of the IP datagram, it must be break into fragments. Identification field is used to identify these fragments. Flag is a 3-bit field which contains 3 1-bit flags to identify if the datagram is a fragment, is it permitted to be fragmented, and whether the datagram is the last fragment. Fragment offset helps to reassemble the fragmented datagram by numbering the fragments. Time to live field indicates how long a fragment will exist. At each hop, the datagram's TTL value is decremented by 1. When reaches 0, datagram will be discarded. Protocol field indicates what type of protocol is encapsulated within the IP datagram. Some common examples are ICMP, IGMP, TCP, and UDP. Header checksum allows IP to detect corrupted headers and discard them. 32-bit source address is the IP address of the sender. 32-bit destination address is the IP address of the receiver. Options field expands the IP protocol with additional information which is not provided in the standard design. Because of these options, IP datagram size is variable. Example options can be security and timestamp. Now let's investigate the IP protocol using Wireshark data capturing. Let's start Wireshark and begin packet capturing. Here I will be using PingPlotter to send different size of ICMP echo requests, as Wireshark traceroute program provided with Windows does not allow to change the ICMP packet size. In the first instance, I will use the default packet size, which is 56, and perform the trace route. Now I change the packet size to 2000 and resume the ICMP request. Finally, I change the packet size to 3500 and resume again. Now I will stop Wireshark data capturing. Let's have a look at the captured trace. I am selecting first ICMP message that was sent by my PC. In the details window of the Internet Protocol part of the packet, you can see the source and the destination IP addresses. The upper layer protocol is ICMP. The header length is 20 bytes. Since the total length of the IP datagram is 56, payload can be calculated as 36 bytes. Here, as you can see, the fragment offset value is 0. So, we can identify this IP datagram has not been fragmented. Next, I sort the traced packet according to IP source address in order to check what fields are constant and what fields are changing in the IP datagram. As you can see, the header checksum and the identification fields are changing. Fields such as version, header length, source IP, destination IP, and upper layer protocol are being constant as we kept them constant. Now let's analyze the series of ICMP replies. We can see the identification field changes from reply to reply as this is a unique value, but TTL field remains constant since the time to live to a specific hop is always the same. When considering the ICMP request with the size of 2000 bytes, we can see the IP datagram has been fragmented into two fragments with total length 1500 and 520. The first fragment's more fragment flag is set to 1, while fragment offset is set to 0, indicating this is the first fragment. The second fragment's more fragment flag is not set, indicating this is the last fragment. When considering the ICMP request with the size of 3500 bytes, we can see the IP datagram has been fragmented into 3 fragments with 2 total length 1500 bytes fragments and 1 540 bytes fragment. The first fragment's more fragment flag is set to 1, while fragment offset is set to 0, indicating this is the first fragment. The second fragment's more fragments flag is set to 1 again, while fragment offset is set to a value, indicating there are more fragments. The third fragment's more fragments flag is set to 0, indicating this is the last fragment.